See if you can go to the Zoom meeting that we have. Can you hear me? What now? Can you hear? There's something moving here. 1, 2, 1, 2. We have 1, 2. So is it one, two, 1, 2. Okay. So every semester we post some of the projects basically here for students to see. Last semester, this was the Verta. Basically, we have actually really good other projects, but I picked one of those. They built this basically. If you just mostly audio, because I can talk on it. So they built basically this e-commerce product that you go, it has a chatbot using LLM. It gets basically it's like an AI agent. It has a memory of you as a user. Basically, you interact with it. You talk about it. I want to buy this product. It reviews all the basically reviews. It gives you some feedback of what's good about it or not. Overall, we saw really good basically ideas and actually converted to a product, like a deployed, monitorable, basically maintainable, basically scalable, because we do all of those basically as part of the learning. And every other semester, again, we have really nice ideas that come up. Like I highly recommend you just go take a look at those, some of these basically projects. And it gives you some sense of what other students they have been doing. So as of previous semester, we started to holding an expo for the MLOPs. Last semester we did, so this semester we're going to do that again also. We're trying to bring more industry partners into it, basically just make it maybe something permanent. But the benefit of that for you is that you can basically showcase the actual product that you have. So you will you get a table like imagine you are going to basically to a show and tell. You have a product, you have a table, and people come to your table and says, "Oh, what are you selling?" So you basically have a monitor that shows the product that you can interact with. You also have another monitor that shows the backend and all the infrastructure that goes into that product. So then you'll be able to answer to questions basically. So For course evaluation, ignore whatever you see over there. I don't care about attendance. I normally care, but I cannot keep track of attendance large class, so I'm not going to do that. So everything basically comes from your final project, 100%. Okay. So from the software perspective, we don't have Jira anymore. School doesn't support it anymore. We basically do TensorFlow, TFX, TFDV, TFMA. Those are different tensor, basically by Google. So TFX is a TensorFlow for MLOps, basically platform. TFDV is TensorFlow data validation, which is as part of the data, you need to have a data pipeline, and that's one scenario. TFMA, TensorFlow model analysis, basically library. Those are all of the tools that we use. And again, you don't need to use this. We will learn other libraries also, but you can basically pick whatever you like. Then we go to learn Airflow, Dataflow, DAS, GCPs, and stuff like that. So Airflow, especially, I don't know if you ever try to apply for ML engineer roles, you will find most of the applications written here as part of those job descriptions. That's why I picked these applications, because I was like, everyone wants you to know this, so it's just let's learn those ones. So Airflow and Dataflow, stuff like that, helps you with automating the data pipeline, basically. You can automate the overall any pipeline with Airflow because it's kind of like an orchestration. But we will use in this class part of the data pipeline, basically orchestration. Then we go to logging, MLflow, and Logstash. So one thing that you will learn in this class is that you need to, as part of any product, you need to log everything, right? Because if you don't log, if something breaks down, you cannot trace it back. So you need to have enough log. So if something broke down, I know what broke down. The last thing you want is that to go through lines of codes, try to figure out what broke, especially over the weekend. That's when it happens. So then we have MLflow is one of those tool libraries. Basically, it's good for experimental tracking. It's just especially one thing that you will see is how often do you have done a project and you have all these Jupyter notebooks with different names, all the file, underline one, file, underline. It's always like that, right? Unnamed one, unnamed two. So tools like MLflow helps you to avoid doing that. Because now it basically can track of every steps, every code that you run, every file artifact that it created, time, who created, what was the result of this month. So you don't need to keep track of those anymore. So that's what we do. Then we have Logstash and stuff like that, which helps you with, I have millions logs now. How could I basically read those logs? You need to stash them. That's the idea of Logstash. So you have it's kind of like a log parser, basically. How to parse, garbage like lots of log into something readable that I can analyze, basically. Then we go to APIs. We work with Fast API, Flask, and I don't know what was the other one, but I think we have 3 in this class. It's not just Fast API, but overall, you need to basically, you have something, you need to build an API. You need to have a proper API that user can interact with. You could have an API for internal use. So you need to basically be able to build those. We will work with GitHub a lot in this course, and you need to also, overall, you need to become a GitHub user as for your career path. We will work with GitHub, Git Actions. Do you know what's Git Actions?
Yes, it is.
Right, perfect. So for those of you that we will learn it, but overall, GitHub is a place that you basically put your codes, like as basically code repository. But also the benefit of GitHub is that it has something called actions. Basically, it allows you to build workflows. That means every time new code comes, certain steps that you want to take those steps. Now, those steps could be CI/CD, just could be simple testing, basically. But we will talk about, so that's Git Actions, what it calls. Then we will go over Kubernetes, with Docker, GitHub, DVC, data version control, basically something that we will talk about. And again, there are more to it. We didn't just name everything here. We will go over Facets, Feast. Those are the tools that you can use for breaking down, like, the concept of what if, basically. It's called what if. So what if this happened, this scenario happened? What would be the basic outcome? So these tools like Facet and Feast, they allow you to do stuff like that, basically. It's kind of like analyzing. Then we work with something called ELK, basically Elasticsearch, Kibana, basically Logstash. That's a 3, it's like a package together. Everyone does ELK. Elasticsearch basically is a search engine by Apache. It basically allows you to do a really fast speed on like a optimized version of searching and indexing. Kibana is some sort of dashboard similar to Tableau, for example. And Logstash, as we talked about, is going to be that whatever is amount of logs, you basically convert them to a readable format. So these three have been bundled together in industry. So logs comes, basically converts by Logstash, goes into Elasticsearch, which is indexing it as some sort of like a searchable, basically database. And Kibana being used on top of that to visualize and build dashboards over the logs that you created. So it's kind of called ELK, basically. All right, and there are more we're going to talk about now. So there are, again, weekly readings. I highly recommend you definitely try to read all those papers that I'm giving you. And again, they are like story papers, okay? Weekly labs. So there are lots of labs that you will see in this class. My job is that to teach it to you. You know, if it's on you that if you want to go home, try it or not. So it's just, again, I highly recommend you to do the labs. If you actually want to learn the concept, just use the lab. The code is there already. You're not writing the code yourself, so just run it. You know, so you understand that what's going on. So we will talk about the project presentation later. Your grading comes from a schema like this, and that's literally comes from your project. So normally, I really don't have any students below A- in this class because all the projects being end up really good. So the only way that you lose points is that when you present your project, I will ask question like, hey, did you do this, for example? If you haven't done it, then there's a certain points that, for example, you will miss. So that's the only way that you will lose points. So I recommend you to read the rest of this basically as you go through it. If you want to contact me, please reach out at this email. I was a student here. I have a student email is reverse, muhammadi.r. If you email me on that one, I don't answer you back. I don't use it, right? And if you email me and you don't get answer back, that means you probably sent it to the wrong one, okay? You have 6 TAs. Questions goes through your TAs. If you are missing the class, it's fine. You don't need to email me because if I don't answer you back, you feel like this person didn't answer back. So I don't need to know. If you are missing it, you're missing it. That's fine, you know? But if you have questions, TAs first. 6 of those you have. If they couldn't help you, then just please reach out to me. Okay, then I'll help you with that. Okay. And if you want something quick, Slack is the fastest way to reach out to me than email. Okay, so just Slack me. That's probably easier. Okay, so that's the syllabus first. Any question on that? Yes.
I see you're recording the lecture. Where will it be available on Canvas?
It will be on Canvas, yeah. So this is the first semester we're going to record the class. Hopefully the cameras works because these cameras are always like a break at some point during the semester. But we will try to record as much as possible. So that's one thing. The next thing we're going to talk about. What's the name of our repository? So we do have. We have a repo for the course, okay? So everything you're basically going to, every useful piece that you're going to learn in this class comes from our repo, okay? The rest of it, I'm going to be here talking and you're going to listen. If you want to learn something coding, productionizing, like Kubernetes, concept, all those concepts, we have the labs here, okay? So highly recommend you first go ahead, fork the basic repo. If you go to basically labs, you have all sorts of labs here. And we have labs from API labs to basically data labs, experimental Docker, and then we're going to all the way to GCP labs, and then we basically have all sorts of labs. Every lab that we have is also basically pre-recorded. So you have the videos for the labs already there. So so what's going to happen is that we have so many labs, to be honest, we can't do those in the class. That's why we recorded those here, okay? So what happens in the class, I will pick certain labs where I need you to basically hear it from me, and I will go over that lab in the class. But the rest of the labs, I already have recorded basically the video for you, the code is there, and I will tell you that you need to go watch it yourself, right? Because again, so many labs, we cannot do those in the class, right? So that's why I'm saying that you need to be basically proactive yourself. Watch the videos, try out the labs basically, and you'll enjoy this because again, maybe some of you have done most of this before, but for lots of you probably it's going to be lots of new concepts. And new concept is always fun to learn, especially if it's not something that you're going to basically struggle with. So those are going to be all the labs that we have. Then let me see, we have on Canvas, we will basically every week on Canvas, basically as part of every module, you will receive a couple of papers. So for example, class 1, there's 1 paper here, there's 2 paper and 3. Those are like a really short, one of them is long paper, the other one is half paper, the other one is really short. You need to read it, okay? Because it's just a story paper. It's like literally survey of multiple companies and they did ML and how bad they failed. That survey does. It gives you some sense of what in reality happens, right? Now, anyone here could guess that if you think about this is actually actual statistics out there, what percentage of data science projects will fail to reach to production? In reality, in industry. Throw a number. 55.
90.
80 to 90% of every data science project never sees the light. Why? Because data, so the reality is that as ML engineer, you have a data science team, they build something that's, they basically do a quick data science work and they build a model, and that model is normally a Jupyter file, basically. They give you this Jupyter file and they say that we have this idea, it works, let's productionize it, right? But the reality was under the, I'm not undermining anyone, but the reality is that data science, basically they don't do a good job on those. It's just everything else on Jupyter. There is no full thoughts around that. Could this be a product? No, it's not their job also. It's like their job is that there's an idea, we want to try to see if it works or not. Most of the time, that idea cannot be converted to actual product because there are lots of bottlenecks or basically lots of basically things around it that is not productionized, right? So, and you can search for that number. It's actually 80 to 90%. The recent basically statistic is that it will fail. It never goes there. Right? So and that's why for companies, lots of companies these days, they want MLOps engineer because they want someone early in the game to be part of those meetings to say that, hey, in order we want to do this, we need this. You want that basically person to be present in those meetings and they give the thoughts basically. Okay. All right. So let's start from here. So we're going to start basically. We're going to start with talking about this machine learning project lifecycle first. Most of the slides for the course comes from deep learning AI, so it's just it's a really good source. But let's just start with this one project that it's here. So let's say you are manufacturing, okay, and you basically you're building cell phones, right? And as part of your basically manufacturing pipeline is that you have this basically conveyor model. There's cell phones basically going on this machine, and it's like some camera. If take a photos, if there's a scratch on the screen, basically you say it's defective. You cannot go to basically outside, right? So basically you build an AI model. That AI model's job is that to look at an image of the cell phone, then detect if there is a scratch. And if a scratch is beyond certain size or certain threshold, then you say that we cannot send out this cell phone, right? So that's the model that you have. That's the task what you want to do. And you have this model basically sits in some sort of like, let's say, for example, prediction server, or it could be a cloud, could be edge, depending on, we're going to talk about those terminology. And what will happen here is that there is an edge device on the manufacturing end. That means that think about the simplest way that you could build a camera. You could basically connect a Raspberry Pi to a simple cameras and kind of put it on top of a railing. And every time something passes, it takes a photo, right? So imagine you have that edge device, just your Raspberry Pi, basically, it takes a photo, and that edge device basically itself needs an inspection software, it needs a camera, it also needs some control software, right, in order to be able to take that photos. It takes the photo, via an API call, makes a call to the prediction server, says that, hey, I took this photo. The prediction server has that AI, basically ML model that basically does the image processing for you. And it gives an answer back, either defective or not defective, right? So that's an example of deployment. And then when we say here, cloud versus edge, you need to think about from this perspective of cloud means that your AI model sits in some cloud infrastructure, right? Edge means that your basically AI model is either sits on an edge device. Edge device could be, this is an edge device. It's like sitting here, it's not cloud. This is an edge device, like a mobile is an edge device. So anything basically that's not a cloud-based and present becomes an edge device here. So it depends on the scenario that you have. You either do cloud or you do edge. We will talk about the difference between these two. But in reality is that if you want something quick, you need to be on edge. Because otherwise you need to make all this communication to the cloud and think about what happens if the internet doesn't work and stuff like that. So if you do self-driving cars, it's always edge-based. Because you cannot wait for this communication to go to the cloud, and it's risky, right? So depending on the application, you decide on the edge versus cloud. Now, then it comes to this inspection that we are basically, you are trying to do here is that, so you're looking basically at this one and say, okay, this is okay, there's no scratch. You look at this one, it's, oh, there's a scratch here, basically is defective. Then you basically, your AI basically, or your tool basically goes on this image and it basically says nothing, or it just doesn't have an answer, or it basically says there's no scratch on it. What do you think is happening there? What do you think is wrong with the image on the right? It's darker, right? But what does that tell you about your deployment?
It's not taking all cases into consideration.
So think about this. When you build a model, this actually really, this is really on me. We will see that at some point. This says that the product manager goes to ML engineer, says that your model doesn't work. Customers aren't happy. And the ML engineer says that, I worked on the test data. The product manager says that, but the customer is unhappy. And the ML engineer again says that, you worked on my test data, right? So if you just always think about that, it works for me, I don't know why it doesn't work, you never understand what's the problem. When we talk about a product, the product is not only the model that you build, it's the whole end-to-end. So one of the consideration, or like one of the parts of end-to-end here in this pipeline is the lamp, the light that you have on that camera. If that light doesn't work, your image quality is bad. Doesn't matter how good is your model, it can't do anything, right? So what could happen here? You could basically, as some sort of due diligence, basically you look at the image and it says that, oh, I feel like there's something wrong with every image that comes from this basically railing, or this basically, I don't know, like a factory, or this line only. And you contact them and say that, hey, can you check if there's something wrong? And they're like, oh, there's one of the lamps doesn't work, right? So if you don't do those, if you don't take into account, if you haven't logged properly that as a login, what could you log? The basic brightness level. If you didn't log that brightness level early enough, you need to do this, all of this manually. But if you can't, for every photo, you have a brightness level, and as soon as the brightness level is below the standard, you basically trigger it. You say that something is doesn't wrong. You don't even need to be involved in this process anymore. It's automated, right? Because the last thing you want is that you spend your time trying to manually go over photos and try to figure out what's wrong, right? So these are just examples of what could go wrong. And unfortunately, this is like the screen also is a bit dark. It's actually a long, basically a scratch here. I see it here, you don't see it there, unfortunately. But anyway, so next. All right. Now, when we talk about ML in production, that's what basically your friend also said. That's how much you code. Basically 5 to 10%, basically. Code as of like ML code, like code for modeling, like what all of us love to do that, but that's like 5%, 10%. Because literally, if you again think about it, pick for your project, put your thoughts together at later when you're doing your project with your team. See how many algorithm you can actually basically try. And you will see that all of those, maybe 2 weeks, I can basically try them all. And just because it's limited number of algorithm you can try basically, right? So then you don't need much time over there. So what does that mean? That means when you basically scope for your project, scope for everything else except for that part. You know, that you have some idea. I'm going to spend 2 weeks, 3 weeks on building a model, basically, for example, here, right? And we're not talking about building, I'm not training a basically large language model here, you know, just building a basically simpler model, or you're just fine-tuning something, right? But even if you think about from the perspective of those large language models, they train it one time. At the moment they hit train, it's gone until they get the model back, right? So it's not like that they basically spend lots of time over there. It's everything else around it is end-to-end basically pipeline. And all this time, if you see that ChatGPT goes down once in a while, it's not because the model is technically, but it's just that something in the pipeline does breaks, basically. So now, this one came out by, this is actually the paper that you're going to read, Hidden Technical Depth in Machine Learning. And this is basically really interesting view. You know, we will see that this table, this basically chart, is almost the same, identical across different papers. It's just maybe they moved around some, or maybe they changed the size of the square, you know, in different papers. But overall, basically, it starts with configuration, which is the same scoping that we are talking about. You're going to spend a good amount of time to do scoping, basically. And then you will see there's lots of time you work on data, anything around the data, basically. That's going to be important. And then you have some ML coding, then it comes from model analysis, resource management, and everything else from here. It becomes around your, now I have a model, now I want to deploy this model, now I want to monitor this model, right? Those are all the processes that you're going to go through. So we're going to talk about this in details, like every pieces of here, but that's the view that you need to have in your mind, should have in your mind, is that there are so many components in order to convert that piece ML code into an actual product. Right? And that's why it makes it challenging. That's why also 80 to 90% of the data science project, they never basically become a product, because these are not, basically, they haven't considered this before building that. You know, there's no, you know, it's just, maybe the model is really good, it works, but maybe it doesn't work. You cannot serve it the infrastructure that you want to serve, right? Maybe it has some basically put the bottlenecks. Maybe it's slow from the perspective of inference, and you are doing, for example, in I work in this like a cybersecurity field. So whatever model that we build, it's normally should be less than 500 milliseconds per inference. Okay, so anything above that, we don't build it. We just go pick different types of model, and to be sure, it's always below that. So if you don't take those into account early enough, you build the model, and then the model like takes 4 seconds, 30 seconds per inference, maybe. Right? But then you cannot use it, because think about the amount of queuing that will go to this model in order to make inference. It's basically becomes obsolete. So now that's what your friend here mentioned, POC, you know. So POC now comes here. Now I have this, right? But there is a huge gap between what I built, this model, and going to a production. And we start to basically bridging that gap, or basically closing that gap by doing something called a POC, proof of concept. Basically, as I said, that you basically have some customers, early adapters, there's different terminology we use for those. You either give it for free, or you say that, hey, if you use it, we give you a certain amount of discount per year, basically, or for the first years or something. And you let that, basically, they let you to run the model in your model in the infrastructure, or basically in their network. And if something went wrong, then there is no hard feeling, basically, because they know it's a POC. And then you get the feedback, and you go improve it, and basically iterate over this process. So that's the whole idea of POC here. And it's really important, especially if you're building something and you're a smaller company, you need some way to basically test frame. You need somewhere to test this, right? So POC is really good, basically, a place to start. All right, now, we're going to talk about the steps that in ML projects are going to, it's going to be the life cycle that you're going to basically follow in this class. It starts with the scoping, data, modeling, and deployment. So scoping again is going to be to define your project. You're going to define what I want to do, can I do it, how I'm going to do it, some idea. The reality about the scoping is that at any time you can change your mind. Okay, scoping, it's not like that is a hard decision, no, because you might have some ideas, and as you progress, you're like, oh, we were wrong. We need to fix it, or we need to change it. The scoping is always something that you can basically go back and change. Even for your project here, we give you feedback on your scoping, and you can go fix it. Like whatever grade you get on your scoping, you can go fix it and resubmit it. Doesn't matter how many times, because this is scoping, that's the idea. We want you to learn that. But then it comes to your data, you start with defining and establishing some sort of like a baseline. Baseline is, we will talk about, is really important because it should be something that you compare this model against, right? Then it's going to be around basically the labeling and organizing the data, which is going to be a huge part. You go to the modeling, build a model, do error analysis basically on that model, sensitivity analysis, deploy, monitor it. And all those lines, as you see the arrowing this back, because it's always going to be a loop. It's not one way. It's everything you will see in MLOps is technically a loop. You build something, you test it, it doesn't work, you fix it, it doesn't work, it just keep doing this loop. And as we will see that when we build this out end-to-end pipelines, most of it is loop. Because you build it, it works now, but maybe in a month it doesn't work and you want it to automate, this loop goes back and retrain and fix itself, basically. So now let's start with one case study. And this case study is going to be a speech recognition. So the first thing is that the scoping stage. So let's say you basically have your own basically consultant company, you're doing ML work, and someone says that, hey, I want you to basically do this project for me, okay? And you're like, okay, what's the project? It's going to be a speech recognition. So you basically, first thing is that you need to sit and think about the speech recognition, come up with some metrics, like for example, think about data and everything that you have, come up with timeline and resources that you need for that project. That becomes all part of your scoping, right? And again, we will talk about this more in details. Then you have that scoping, like the first step then comes around your data. And this is before building it, when as part of the scoping. Then you need to basically decide, okay, what is the data? Do you have data? Because someone came to ask for you for this, to do this project. So you ask this, do you have the data? Okay, if you have the data, is the data labeled basically? Yes. Is the label consistent? I don't know. So we will going to break this down to understand what does that mean. So think about it when you are listening to an audio. So you do a speech recognition, right? And you hear something like this in one audio, today's weather, and the other one says that, today's weather, and the other one says today's weather, right? So think about perspective of labeling. Are these three the same? Should be the same basically thing from the labeling perspective, right? Or from perspective of silence, today's weather versus today's weather. Just the only difference is the amount of silence basically goes through. It should this be the same thing, same data? Should we handle it the same, right? How do you perform basically volume normalization? These are the type of questions that you're going to do before basically trying to build something, right? Then it comes basically to your modeling part. Now, so in one thing that we will see is that there are two views on building models. One is research and academic views, and the other one is just like a product team. So can anyone make a guess? What's the difference between academic view on model versus like an industry view?
Academic is more like optimization.
Optimization.
It's
Right. What else? That's correct. Can you say it louder? All right. So what does industry project is focusing on?
Complexity of the models that have
how complex it is, and in the industry, we want as simple models as possible so that stakeholders can understand.
Right. So these are all correct. So think about this. In academy, as your friends here say that, every once in a while, there's a new paper out, right? And there's a scoreboard. Everyone tried to beat each other on the same data with a different algorithm. You just enhance the algorithm over the same data. Data is constant, models are changing. In industry, it's reverse. Model is almost constant, data is changing, right? Because you have a lots of data, you don't need to play around with models. All you need to is to be sure that you have a proper pipeline that could work with any data, right? I don't need to have the state-of-art algorithm out there. If I have a proper definition or proper basically design, my smaller model may probably going to get me a better result, right? So that's the main difference between academy and basically industry view. But all of those basically you have code, hyperparameters, some data, and that goes to a model. But overall, the ML system is going to be code plus the data. So that's the part that up to this point, you basically look at ML model as a code only. But what we want to learn here is that ML system is code plus the data. Because a big part of your end-to-end pipeline is the data. Not only the data that goes to the model, is the data after you develop the model also. Because when I develop a model, I have a data and I basically do all this analysis to get the best out of this data. But also that data gives me some characteristics, give me some schemas that I need to basically be sure that any new data that I receive in the future from customer can match to that schema, can match to that property statistics of my training data. If it doesn't match, of course your model is going to perform bad because this data has a different characteristics. So data is going to be an important part of your ML pipeline. So ML system becomes code plus data. Now, so let's go to this concept of deployment. So you had this for the speech recognition, you have this model now, basically you want to deploy it, right? So again, you have this prediction server with your AI model basically sitting, and there's a cell phone basically, and users basically try to do a speech recognition. They are using your speech recognition algorithm, for example. Now, the first thing here that you remember here is that as part of monitoring, you need to monitor to be sure that something went wrong. If something went wrong, you want to know it so you can fix it. But a mistake that we as engineers could do is that only to monitor for anything related to my ML model, right? Why that's wrong? So think about basically speech recognition, or like think about your Siri, right? So every time you hear that, say that okay, they're listening to us, like a Siri is listening to us. So do you know what's the reality, like what's happening? So there's this, this VAD, voice activation detector module, right? It needs to be on your cell phone, right? So why? Because so Siri becomes activated, right? But there should be some piece of software, or basically that tells to Siri, hey, there is something, right? So this VAD basically is listens for, it's always listening on your cell phone for, I think it's like every 4 or 5 seconds, it depends on company, I don't know the actual number, but it's basically, it doesn't save that information. So it's just basically data that comes through, so it listens every 4 seconds. If it predicts that you are going to call to Siri, it activates Siri for you. So that's that VAD, that's that listening concept that people talking about. So you have on your cell phone, yes, it's something is listening for 4 seconds, 3 seconds, but memoryless, basically, stateless. But its job is that it to detect and to activate the Siri for you. So that VAD, it's something that you didn't build. Your company didn't build that, right? So what happens is that when you, all of a sudden it says that my software doesn't work, customers aren't happy. If you only think about your software, where's to say that, let me go check the microphone and VAD of those machines. Because you have some information that comes. So for example, you go and you check and it says that this VAD recently had some software updates, and that software update caused some sort of bugs, and that's why the quality of the audio is bad. And that leads to your basically speech recognition tool to not to work. If you only think about your piece of software, you're going to basically go in this rabbit hole and you're thinking of, I cannot find any problem, but the problem never was your software issue. It was actually the piece of, other hardware or software that you are utilizing in order to run your software. Okay, so those are the things basically that you want to keep in mind. Any question on that? All right, so now, as part of the course outline again, we're going to work on this one, this 4 basic concept. Optional is not, scoping is not optional here. Into scoping, reverse data, modeling, and deployment. And then you will have, I think we will post the scoping probably sometimes over this weekend. You will have about 2 weeks to figure out your teams and to figure out your basically project that you want to work on. And again, the scoping is something that you can change as you go, okay? So now let's talk about something on the deployment side and what are some key challenges that you can have as part of deployment. Because I know everyone here wants to learn how to deploy that machine learning model, right? So the first thing we're going to talk about is a concept called concept drift and data drift. Okay, so the first thing is about the term drift. Drift means anything that is on a time series based changing between 2 time stamps, that drifting. So if you basically heard the word skew, data skew, we will talk about that later, but skew means batch version of the data. So drift means time series basically change, basically, okay, over the time. Okay, so when we say concept drift versus data drift, so data drift means anytime we refer to something about the statistical or something about the nature of your data, your input data is changing. That becomes data drift. Like all of a sudden, the demographic of my users have changed, the age group have changed, stuff like that. So that becomes data drift. There is a drift in basically shift in the statistical configuration. If this mean was previously like 12, now the mean is 14. Right? That's a drift, basically. When we talk about concept drift, so concept here means label, that Y, that, X to Y, mapping, that becomes a concept for you. So when we say concept drift, means that the actual labels have changed, right? A simple example, again, is just, could be, in fashion, once in a while, something is really popular, and in a couple of months, no one buys that anymore. That's a concept drift. Today, my AI need to predict, let's order lots of this. In 6 months, because of there's something happening, my AI says that don't buy that because there's some socioeconomy or basically something happening on internet, no one wants to buy that anymore, right? Or concept drift becomes the same thing that happened during the COVID to credit card companies. Everything that was your credit card was saying is fraudulent is no longer fraudulent. So the label should change. So you need to basically retrain the model. You need to change your model. You need to get rid of the old data that you have, because now that old data that you previously were saying this is fraudulent is not fraudulent, right? So that becomes concept drift. Another example is that if you think about books, if a couple of years ago, you ask somebody, for example, this is just a model, for example, says that you show a book on a tablet and says that if this is a book, the model says not a book. But right now, a PDF is a book. Right, so that's a concept. The concept has changed. The definition of label has changed, right? So that's a concept drift and that's a data drift. When it comes to data drift, the drift could be sudden or it could be basically a slow drift, or basically a sudden drift. The concept also basically had the same thing in COVID. During the COVID, that was a sudden change. Quickly something happened, right? But another type of concept drift could be seasonal changes, right? That becomes basically a slow drift. When it comes to data, you could have a sudden change in the characteristics of your data, or you could have a slow change. Sudden change could be maybe all of a sudden you have a competitor in the market, and all of a sudden you lost your lots of customers. So there's a change in the data that you have. Maybe your company all of a sudden starts selling the product that you have to a different region in the world. Now you have a different statistical, basically, information around customers. That's sudden, because all of a sudden you open the market to there. A slow drift could be something that happens over the time, and as part of you monitoring it, you're detecting it. You monitor and see that every month we have a 1% increase in certain thing, and you can predict it, interpolate that this is going up. So if you can detect that, it's because it's basically a slow drift. I know in 6 months I'm going to have this much change in my data. Right? So if you can predict something like that, especially, you don't need to wait. So you can proactively basically try to fix that issue. So then, that's one concept, one problems of the deployment is the concept drift and data drift. And that's why you need monitoring. Without monitoring, you won't notice those, okay? So the next one comes around software engineers issues. And that's what, like, is it real time or batch basically deployment? That's a really important question, because if it's a real time, you know that you have a limited options on number of types of models that you can use, because real time means quick prediction. Think about it, for example, when you're trying to buy a ticket to go home, right? So it's like you go on a website, you want, like when you hit search, you want to answer now. You don't want to come back tomorrow to see what was the price, right? That's a real time prediction. Whereas a batch prediction is that you basically submit a request to bank, and bank doesn't give you answers. Okay, we will contact back you. Maybe that they collect certain number of basically requests as a batch, and they pass it to a model basically to make a processing. So if it's batch, because it's not on time, I could have a much larger model to do the job for me. If it's real time, we need to be sure that my model is fast. Fast model means that it cannot be large, right? So it's just there are some basically trade-off here. Cloud-based is edge, it's like, does it go from the cloud or going to be on the edge-based basically? That also defines the types of model that you can use. Why? Because if you're targeting to sell, for example, if you're selling to cell phone, if you're building an app for cell phone, I think right now the best cell phone has a GPU of 4 gigabytes. The GPU on the best cell phone is 4 gigabytes. So you can't build a model that hogs 4 gigabytes of GPU, right? How many times when you go, like, probably, I don't know if you noticed that, if you try to take images a lot with your phone, like so many in a row, it gets to the point on iPhone, if you hit picture, it freezes almost. And it gets after a point that you feel it's hot, right? Because if it uses GPU, it starts getting hot. So you cannot build an app that hogs the GPU every time user wants to, because user will like, I don't want this app. They basically, uninstall it. So latency, throughput, like how latency means that if the moment user hits request, predict how fast they get the answer back. All the way, data going through and data coming back, that becomes the latency. Throughput means that how many requests at the same time I could basically answer, right? So those are important for the deployment. Logging, as we said, is going to be really important. You need to basically log enough. Also for your project, at first, my recommendation is that log as much as possible. And as you go through it, to basically trim those logs and just get rid of prune those, get rid of the one that you don't like. At the beginning, you don't know what's important, so just log for yourself. And security and privacy, which is also going to talk about it a lot. It's really important. It has been proven that you can easily basically fool the AI models. It's just a simple example is that adversarial attack. Basically, you can basically introduce noise to image classification model, and that image of a car, and so with a certain noise, the model will predict a panda. Right? And people who try to hack or fool the AI models, they will learn those and they use that to their benefit, basically. There's lots of basically security and privacy issues. And privacy comes that you can try to figure out whose data was part of this model training, okay? So the next question is, as part of your deployment, is it like your first deployment or is it like something that you're maintaining? Because if it's your first deployment, that means your company hasn't done that before, there are lots of challenges. Right? It's your first time, you maybe don't know it, and, it takes probably more time. Versus if it's something that you have done before, you may be updating the version or creating a new generation of the model, but you have already a pipeline in place. That's much easier. So those are the things that, just you want to keep in mind. It's like first deployment, maintainable. Then when you deploy, how do you deploy? How do you basically push this model out, right? Like what are the strategies that we can basically have here? Now, we're first going to basically think about like, again, is it a new product or is it existing capabilities that we deploy out? Is this something for automating or assisting a manual task? Is this something that replacing a previous basically ML model that we have? And here basically we will talk about gradual ramp up and rollback concept, okay? So let's start with this one. So let's say for the same example that we were talking about, so this is you currently have human in the factory and they basically they're basically standing on the basically lines and look at images and they decide if the phone is good or bad. And you're like that, you know what, this task is not fun for any human to do. I'm going to basically automate this task with AI, which is really important, to just be sure that you use AI for tasks that is not fun. Don't use AI for tasks that someone is having fun with it. It just that should be some sort of reality. So what you do, you build an ML model and like a humans looks at basically this says this is a scratch. ML looks at it, says this is a scratch. And human says no scratch, ML says no scratch. Human here says there's no scratch, ML says there's a scratch. So basically you try to use this at the same time. But the idea here is that, can I just push this ML out, right? Can I just test it out like this and just push it out, right? Now, the answer is that no, you need to have some strategies for deployment. One of the simplest strategies is called canary deployment, okay? So canary deployment, basically the idea is that you roll out, let's say, I have users, for 5% of the users randomly, I give them the new model, right? And I just wait and see what's gonna happen. Who's gonna shout, who's gonna complain. Like all the companies they do is that probably, have you ever had friend on Instagram that says that they have some options on the Instagram that you don't have? That's the concept of canary deployment. So some people get some features as a test. They monitor basically all the tweets about it to see that if everyone is happy with it or not. If nothing breaks down, then they start to basically roll it out to more people. Why do we call it canary deployment? So you start thinking about, you try to see that if something breaks down, I want to basically know it in advance. Back in the days when they had this mining, when they used to do mining, and lots of old cowboy movies, you see those in it. And then they always, when they mine basically the workers in the mine, they have a canary in the basically in a cage, and put it at a really far at the end of the tunnel. Canaries, they smell the gas much sooner than the humans, and they start basically singing, shouting. It's just something brutal back then. They used to do that, but then that basically they knew that something is wrong. So here is the same story here is that, so you want to have a way to know in advance something is going to break down. So you pick 5% of your users as a test and send it out. And if they're complaining, you roll it back. If not, you make it 10% and so on. And so it's just gradually you increase the percentage. So the next strategy is called blue-green deployment. And this is a scenario when you already have a model in place. You just want to replace that model. So you have an old version of the model, and you have this new model that comes. In the blue-green deployment, you're using something called like a rotor, right? A rotor job is to basically change the traffic. So you have this model, when it's ready, this rotor, all it does, it just redirect the IPs, basically the traffics to the new one. No one will notice anything, right? But if something breaks down, you still keep that in the loop. If something went wrong, you basically return basically the traffic that way. So that's called blue-green deployment, okay? It's a scenario if you already have a model. If you don't have, then you maybe do something like canary deployment or gradual rolling. Now, So think about the idea that we talked about, that there's a human and there's an ML, right? And they basically want to decide that, can I use this ML model to basically do the job as a human? There are some steps that you can take in industry. First one was the human only. Then you basically, the second scenario is called shadow mode. Now, what is shadow mode? Shadow mode is that if you go back to this example here, AI or ML basically is there. It makes a decision, but that decision won't basically have any impact. You basically don't use ML as an basically tool to take action on. You just use it as some shadow mode. So human make the decision, effective or not, but AI also makes a prediction. You monitor both and you collect those. And you take that data and you take it for analysis to see that, hey, you know, if it's good or bad. So that's a shadow mode. Okay? That's a way if you want to understand that if your AI model is good enough. So you still use the human, but the shadow becomes the ML becomes the shadow. The next one is AI assistant. And that's a scenario that you use human and AI at the same time. AI will assist human. How? AI basically points out, like visualize the areas of scratches for the human. Says that, hey, I see this area. If you missed it, look at this area. That becomes like an assistant, right? Then you have partial automation, and partial automation could be, for example, you still use the human, but you have also ML basically is in it. You either vice versa. You first use the ML and then pass it to the human, or you use the human. If human say this is a scratch, maybe you pass it then to the ML and says, hey, what do you think now? It's kind of like an, you know, it's kind of like an assistant, automation, partial automation. And then you have this full automation, which in it's not many companies out there that do full automation. It's this type of thing. You know, we want to go toward it, but it's not. It's still not that common to be full automation. So we are basically lots of time in this region. Okay, and also depending on the types of tasks, that's also impacting these decisions. All right, let's take a short break here. Thank you, sorry. All right. So metrics to monitor, again, we say that there are some software metrics, basically there are some input metrics and output metrics to do that. But when you monitor also, you need to also answer this question that how quickly something basically will change. How fast the drift will happen, how fast the change has happened, right? Now, there isn't this idea that normally user data basically changes slower because customers, we don't change that quick, we as a customer, right? But companies' enterprise data can quickly change. The company, like all of a sudden, maybe a school decides to update their systems and they update their machines. It could be in one night, they do lots of changes, right? That could be a sudden change. But user perspective, we always we have a really slow drift, basically. So, all right, let's go here. We're going to talk about this drift concept that we are saying concept and data drift. So what could go wrong? Let's start with that. This is the idea of when we say drift happen, when we say change in the statistical characteristics of the data, this is what we mean. So you have a data, let's assume that by default it's some sort of a Gaussian curve basically, and this could be height, weight, whatever, right? Age, and as time goes and your new customer basically actual customers basically come over the year, you notice that there's a shift in the distribution of your user. Right? That's, for example, something that happened to Facebook. Facebook was popular. Now, if you look at the distribution of the age that they're using Facebook, it actually really has changed, right? So younger people, basically, they don't use Facebook. So that's a change that could happen here, right? So it's kind of like a drift has happened slowly, gradually. Now, and this is concept of, again, model decay, model accuracy will go down, anyway will go down. Your goal is that to trigger it, retrain it, and basically slow this process. Don't let that tip happen so quick, okay? So just slow down this process. And again, this is really interesting. No model lives forever, but the speed of decay basically varies. So now why models drift? Why model performance goes bad? It's like if the model is working good, you test it on lots of data, why that will go bad? And the reality is that most of the time, the models go bad because the data will change, right? Because the model, if you think about it from the perspective of a model is a frozen object, right? So it's not that the model itself, weights has changed or become bad. No, the model is no longer good with respect to the environment or the data that is being used on. That's the idea behind the model drift. So, model drift happens either because data drift happened or concept drift, means the label has changed basically, or a combination of both of these pieces. So that becomes the idea of model drift. Now, when we talk about data drift, so we say that data drift means that, there's some features of the data basically is changing. So let's think about the example. So here is an example of the, you have basically bought this data, and this data comes from paid search, okay? And you build a model, for example, over there. So in order to build a model, you paid some company and they basically collect this data. This is search data, basically, they give you. You build your model over there. Now, as soon as you basically try to test that model, you basically, let's say your new data that comes from social media. Right? So the distribution of these two data, by the nature of these two data, are really different. Search data versus social media data, right? So it's like a paid search, paid social media means that, you pay to, for example, Instagram put this ad over there and see what traffic I will get from there, right? So the data that you receive from those two, they have a totally different distributions. Who is on Instagram versus who is on Google clicking on basically an ad. Right, so it's going to be a different distribution, and that's basically what we mean by basically data drift, because this will lead to your model performance to go down because you built the model over a data that was over paid search, this red, But as soon as your data becomes paid social media, the performance goes down because different characteristics, different statistics, different age groups, I don't know, different demographics, all of those basically impact the model performance. Now, this becomes another example, like for example, increase in mean and variance that could cause basically be a drift from you. This could be age group that could change. Now, there's a term here, train serving skew, okay? This is like a, probably you can somehow relate it to the concept of overfitting. You know, overfitting, when we say, that in a layman term in the school, we say overfitting is that you build a model on trained data, when you test it on a test data, doesn't work. That's a way we have been in the school saying overfitting. But the reality of overfitting actually is that it might work on also test data. It doesn't work on customer data, basically, right? So that term, basically here, we call it training serving skew. That means the skew, again, remember I said that if it's a difference between two batch, not time series, not time-based, two separate batch. Maybe this data from this year, maybe this data from next year. That's like a skew. But here the idea is that you have this data, training data, and you have a lot of it. And you build it, you test it on a validation, you test it on testing, perfect, work fine. As soon as you send out this model out there, your customer data looks like that, right? Your customer, they don't have that data. They have this data. So that becomes training serving skew. There's a skew, there's a full change between train and serving time. And this model is going to, so when train serving skew happens, your model actually breaks or basically goes down the moment you deploy it, not gradually. As soon as you deploy it, as soon as first customer comes, because the data is really different, everyone complains. This doesn't work. Everyone uninstall the app, right? That's because the training serving skew basically has happened. So it's not gradual, it's sudden. Now, when we talked about concept drift, and I say that the concept drift is like when the why will change, it also could be gradual or it could be sudden. Gradual concept drift, you know, scenarios could be a competitor launch a new product, some macroeconomic changes basically is happening, some mechanical wear of equipment, something is changing that basically causing that concept, the label is basically changing, the class values basically is changing. Now, if we go to sudden concept drift, it's something that this will basically happen, you know, it's like all of a sudden that happens. And this is actually a really interesting example. This is, I think it's for yoga pants, yeah. So this is a sales for yoga pants and this is where the lockdown happened. And this is what actually happened. This is what the models were predicting always, right? So 350% increase in a sale of yoga pants. It doesn't matter how good is your prediction model, it will fail. Right? Because like, even they try to update the model, probably the model tried to follow, couldn't reach to whatever you know, the demand was. So that is when the sudden basically drift will happen. Now, how fast the models basically age? There are some ways that you can estimate. Basically, you could basically look at, you know, the performance of your model and somehow interpolate that. How long do you think it's going to get for your model to get to certain basically behavior? Then you can estimate that enough, early enough. But you can basically, you can even do that over your some sort of like a test data that you have, maybe gradually adding. If your data, you have your test data is like a time series, you can do some moving window and monitor that. What happens if I see this data that I haven't seen before? Now this data, like basically how much variation I will have. And based on that, you have some idea before deployment that this model might work for 6 months, 8 months, for example, before it definitely basically have a drift in it, okay? We're going to talk about those later, basically. But now the question here is that if this drift happened, what should I do as an engineer? What's the process that I need to go through? So the first question that almost everyone has, even myself, always like, if when drift happens, like it's not an if drift, when drift happens. Actually, I was like, should we retrain or should we fine tune? It's kind of like it's a big decision, retrain basically could take days, because if you retrain especially a larger model, fine tune maybe could takes half a day. It was much smaller, right? Or shorter. So you need to decide on those one retrain versus fine tune, and those are not something that doesn't have a rule of thumb. It just, you need to look at the data, how much change you had, how much drift basically happened, how much my model is still useful or not. Basically, that based on that you can decide if only a small portion of my data was changed. Maybe I don't need to retrain. I just fine tune, right? But if lots of my data has changed, then maybe I need to basically retrain, right? So one way of thinking about this is that imagine you have this data, and let's say you have four classes, for example, that you're predicting A, B, C, D, and there's some concept change basically, and you monitor that, and you notice that A, it's no longer valid. Like the label should change basically. There's a concept change, okay? Let's say A is like a 20% of your model, of your data. Now the question here is that I will monitor for this tree, how good I'm doing here. If I see this is constant, like a good, like a similar to what we expect, right? Then I'm like, maybe I don't need to touch this tree. I just directly go on this one. So what you could do is that if this has a concept change, you cannot use this data anymore. It's not useful, right? So what you could do is that, I mean, there is a way if you can relabel it, maybe you could, but the reason you detect there is a drift here is because you already have new data A prime. Based on that, you knew there's a drift. So what you do basically is that you replace this with that, and now you have all three the same, and you maybe do a fine tuning. As part of your fine tuning, what you do is that you still passing some portion of B, C, D, because you don't want your model to forget those to every epoch that you have, for example, but you keep introducing a lot from this one because you want your model to forget this, learn that, but at the same time, you want your model to remember those, right? So as part of refinement, there are some decisions. Should I basically totally retrain, or should I fine tune? If I fine tune, what should I do with the data? How should I fine tune? Because again, especially for neural network, the good thing is that they are frozen, so you can continue from that state, right? But all you need to do is that be sure that these ones are part of that refinement. Otherwise, your model will easily forget this. Okay. So now the other concept that you have, it's recurring concept drift. Right? Types of concept change that happens on seasonal base, right? And this is common, like in airline, basically industry, every time near the spring break, the model knows that the price should go up. They increase the price. Uber knows on weekends, certain time, they also announce it probably is like a price surge. Right? So the model knows that there's a price surge, right? So for example, not that they do it like this, but let's say, for example, you have this one column that says that surge, and that column is either 0, 1, right? If it's a 1, because now it has a certain weight, it's like multiplied by the weight and adjust the price by that much. If it's not a surge, it's 0, so you just have it without that surge. So that becomes like a simple scenario if I want to introduce a seasonal basically change. Does that make sense? So, and this is just an example of the seasonal. So over the weekend, sales goes off. Over the week is basically normal. And you want to be sure that your model can basically address all those scenarios. All right, so let's go here. Now we're going to talk about something interesting. So this is like a really interesting post by Google. I always actually like this line. It's companies that fully absorb AI in their value for producing workflows by 2025 will dominate the 2023 world economy by 120%. So it's just AI is going to become a big part But we need to be sure that this AI that we built is actually, it's working fine, it's trustworthy, it's basically doesn't have bias, it's monitored for securities. You know, it's just, those are the type of thing we want to basically make it happen. And that's why the concept of MLOps, the way that you need to think about MLOps, it's technically is a framework. You know, MLOps should be a framework similar to DevOps, basically. DevOps is basically a set of practices that you apply to software engineer, and that's how software becomes really popular, right? Software wasn't that popular, so had lots of issues until this concept of CI/CD become really popular, and then software basically bloomed, right? The same thing for ML, that's what we want to do. ML, right now, it's not that successful. Again, lots of projects will fail, lots of challenges in it, and it's not because we like the engineers are not good. It's just because we haven't done that. Like we didn't think of ML to become that popular. So now we are dealing with all this, you know, learning curves, basically. You know, so basically the idea here for us is that we want to be sure that similar that to the DevOps that we introduced CI/CD. And for those of you that don't know, CI/CD is like a continuous integration and continuous basically deployment or development, however you want to put that. But the idea here is that think about simple scenario that you have this, your GitHub, right? And your team basically works here, and then let's say a new code comes to your GitHub. So this is like a new code. And your ideal pipeline is that whenever there's a new code that is approved and not just a new code that's pushed, new code that's merged, you know, is ready. I want this GitHub automate like this process for me by automatically integrate, and this continuous basically integration, CI. So continuous integration basically means that you pick the code, you run a series of tests against the code, be sure that this code can integrate in the deployment basically servers that you're monitoring for, you want to send for. Like you just try to see that it passes all the tests, is integratable. And then if yes, basically it's kind of like it's packaging it. So continuous integration, it basically creates this package. And then you go to continuous basically deployment or basically development, or you want to call that again, CD. And the CD basically his job is that now I have a piece of software, it's packaged, tested, and I want to basically send it out. I want to send it to a customer. I want to send it to wherever I'm deploying it to, right? It's kind of like before doing that, you still do some tests in CD also, like maybe you do a test over like the package that I received, I'm going to unpack it in a certain environment and see that it can run one more time. And then if yes, I basically send out the code. That becomes the automation, CI/CD here, right? But when it comes to ML, something is missing here because this is only the software, right? In ML, you have two different concepts that we are going to introduce, right? And it's called continuous training, continuous monitoring, CTCM. So for ML, you're going to have a CT and CM, continuous training, continuous monitoring. Continuous, basically maybe at first we go here to monitoring. Continuous monitoring means that when you send out a package, and the package here is the model, that's not the end of the pipeline. You need to monitor 24 hours that model to be sure that everything works smoothly. If something breaks down, you want this process to be automated. You want this, if something is breaking down, to trigger this one, continuous training. And continuous training's job is that, okay, we know something is not working, we're going to train the model. We'll update the model, or basically whatever we do here. And maybe this one, after it's done, it basically send it back here, goes to integration again. Because now you want to do CI, CD, and send it back as a model. And then again, you will be monitoring. This is kind of going to be the loop here, okay? So this terminology was introduced, I think 2 years ago, something like that. Here, CI/CD, CT/CM, okay? So that's the two new terminology that you remember, because ML is not just the software, it's actually that's like a total, you need to think about it. I have a model, after the model, what's going to happen? So you monitor the model and then basically you're going to retrain the model. It's just kind of like an automated fashion. So yeah. Any question on that so far? All right, so for, let me first refer to this before I forget this one. This paper that's here, challenges in deploying ML, it's a survey. Definitely review this, you know. It's just, again, there's nothing technical in it. It's just like a book, it's just read it. But it's a really interesting paper, so I highly recommend you to read it. So. Okay, now we start with the scoping. Again, not optional. Okay, so because the first thing comes also for your project is going to be the scoping part that you want to do. But we're going to talk about what is scoping, you know, and think about that the scenario that we are basically we have this, let's say this use case here, and you are basically, someone comes here and says that, hey, we have an e-commerce. And we are interested to increase basically our sale. That's what they're trying to do. They try to increase their sale. They come to you and says that, hey, we want you basically to build something to do that for us. So the question that comes to you is that in order to increase sale, should I build a better recommendation system? Should we have a better search system? Should we improve the catalog data, inventory management, price optimization? All of this could be a reason for a way for increasing the sale, not necessarily need to be ML based, right? So then the questions basically you have here is that what's the project we want to work on? What are the metrics for success that we have here? Like what at the end of this project, I build it for you. How do you decide if it was successful or not? You need to have some idea. What are the resources, data, time, people that you need for doing that project? Now, overall, zoom in. When it comes to scoping, you need to basically try to do a couple of basically things in your mind. First is that identify the business problem, not AI problem. What is the business problem? What is that you are trying as business to solve? What's the product you're trying to basically solve? What is going to do? Not the AI, you know? I'm trying to, like from business perspective, I'm trying to enhance my customer experience, right? That's the idea that you have. We are not talking about how you're going to do that. It's like, what's the business goal here that you have? I'm trying to enhance my customer experience because that will improve my sales. Like that's just an idea that business. Then you talk about brainstorming AI solution, like what AI solution that we could have here? What's the expectation from AI, from ML here, right? Then you basically assess the feasibility of this, like how feasible is that AI solution? What's value it will basically has, you know? There's a type of questions that you need to answer. And then as you go, you determine a milestone. Okay, what are the milestone? How at this, I don't know, like quarter, we're going to develop this, next quarter, we're going to develop this, and so on, right? What's the budget for that? That's always the most important one that comes at last, but it's like, what's the budget? Do you have the money for it? It's like a reality. Could we do it? So now let's say you ask you this question, what are the top 3 things you wish they were working better? And so it's like, I want to increase the conversion. Conversion means that, you know, when user comes on the website, a user converting to a buyer, that's a concept of conversion. Conversion rate is like something that you optimize for. Reducing inventory, because so increasing the conversion means sell more. Reducing inventory means you sold more basically, you know. Could be not that you ordered less, but you sold more. increase the margin or profit per items, like I want to increase my margin. So these are type of questions basically that comes in. Now, you can basically create some sort of like a table of what to achieve, how to achieve those. And let's say, for example, increasing the conversion. In order to increase the conversion, have more customer to buy, maybe I need to have a better search or recommendation system. Right? How to achieve it? That's the idea here. In order to reduce the inventory, maybe I need to have a better demand prediction or better marketing strategy. Right? Increasing the margin or profit per item, maybe I need to optimize what to sell or do some bundling, you know? So these are type of questions that you will receive. It's good for you to have something like this. What we are trying to achieve, how could we achieve those? Sometimes you will find that that's the case. It happens actually in reality more often than you think. That when you look at this, you're like, okay, this is not ML based. You know, it actually doesn't need an AI behind it. Maybe you can do something else. You know, so it's really important for you to have this idea of what's the goal, how you can achieve that goal. Now, you want to also part of the scoping to diligence on feasibility and values. And so feasibility of a project is actually means different things, but we're going to talk about one thing here is that technical perspective. So let's say I'm doing basically, so anytime we talk about ML products, there are two techniques, if you think about it, there are two scenarios. You're either dealing with structured data or you deal with unstructured data. Structured data, anything is tabular, I don't know, like a database and stuff, it does not have a structure. Unstructured, audio, text, image, videos, those have become unstructured, basically data. So it's one of these two scenarios, it's not outside of that. So when you try to understand feasibility of the project or ML basically solution, let's just start with the unstructured, again, image, audios, and stuff like that. So there's two questions that you will ask. You as this is assuming that you are building the product for somebody, or for yourself. Is this product we built, is it a new product or it's an existing product we improving it? It's one of these two scenarios, right? So first question is it unstructured? Yes. Is it a new product or is it existing? So it's one of these two scenarios. Now, when we deal with the unstructured data, audio, image, and stuff like that, who do you think is the best judge to compare an AI against? If you have an AI model over unstructured data, and you want to compare it against some baseline to see how good is your AI model, who do you think should be that baseline? Humans. Right? That's why this is called HLP, human level performance. Humans, I don't think it should be a surprise, we are really good at unstructured text or data. You can look at an image in a second better than an AI describe it. Right? See so many details in it, a video, an audio, listen to a song, reading a text. Right? So when it comes to unstructured, we are comparing humans as a source of truth because they say that humans, they're doing good. Basically, you want an AI to, be as good as human in order to be say that this AI is good. There's some components, there's some tasks, actually AI does better job than humans. It's like proven over the years, larger models especially. But overall, human is the baseline. An AI model that doesn't do as good as human in a task like that maybe have a hard time to sell in the market. Right? So human level performance is always the baseline. And let's say, so you're building this unstructured task as a new product. As part of feasibility assessment, you need to ask, can human do this? If I give this data to humans, can they label it? Right? So let's say, again, I give this image to everybody and I get like 51% to say yes and 49% say no, right? So what do you think the AI will predict? 51%, right? Correct? It's like if you label that data, 51% say yes, 49% say no. The AI, because majority says 51% says yes, right? So that's the reality of this. The label that come by humans are like, we have this imbalance, and not imbalance, it's like a challenge in labeling agreement, then that data is not good. That task is not good for AI also. You want this type of task for unstructured be something that is easy to detect, not easy to read, but is something that's feasible. Human, they can do it. If we can do it, then you can expect the AI to also perform it. If we cannot do it, then that's a hard decision that I'm expecting AI. Think about an image, like a traffic image. Like you have a traffic image and there's a really bright light hits into the camera and all these images, you can detect which light is on. When you look at it, like, I don't know which one is on. If you don't know it, you cannot see it, probably AI also cannot see it. Most likely, maybe if you do so many levels of convolution, is just try to go deep. Maybe AI for some of those images it can do, but in reality, no. So human level of performance is the first thing you always need to remember for unstructured tasks. That's how we label, basically. So if it's an existing project, you still have human level performance, but you also have the history of the past. How good we were in the past, right? Like, could we still do the same thing that we did in the past? You know, could we improve it, but doing better than that? When it comes to structured data on the other end, what do you think is, like, what would you say about humans, about the structured data? How good do you think we are? We are really bad. Put a table in front of yourself. After 10 columns, you cannot answer any question about it. You can't. Now think about a large table in front of you. Can't say anything. Like numbers, they don't make any sense. So humans, we are really bad on anything is structured because we cannot memorize. We cannot understand. We cannot. Our brain is actually correct way is our brain is not trained to make sense of those numbers. Our brain is trained from moment we were a kid to about listening, watching, you know, just that's why we're really good at those, right? But numbers now we are not, like, we can't do that. So when it comes to structured data, we don't use human. We actually try to basically do some other tests. Like, for example, if it's a new project, the first question that you need to always ask is that, is there a reason we believe this data can predict that task? Is there a reason you believe this table can predict this classification or it can predict this number? That means, is there any predictive features available? So you do some sort of a statistical test, maybe see that if there is any reason you believe this, whatever data that you have actually can predict whatever task is over there, right? If yes, then sure, we can build it. If no, then no, you don't have a good data for it. If it's an existing, the same thing, for the new data that it comes, is there believe this is there's a new features, right? What's the history of the project, right? So you need to basically always have this type of questions that you are asking before accepting something. Can we do this or can I do that? It's like a feasibility test, you know? Does that make sense for everyone? All right, so actually we have this here. Why human level performance? So what's the light do you see here? Oh, you don't know, actually. This could be red, could be orange, could be green. This one is green, that's green. This is, I don't know. So you might say green, but it actually might have been red and the car goes through and then you have an accident, right? So that's the problem. If humans, we have a hard time reading all these images. Again, AI might be able to read some of those, but it's in the wrong expectation that, because you don't know what's the correct answer. Because anyway, for the AI also, you needed to label this data, right? So whoever labeled it is a human, right? So whatever, if your friend here thought it's green and I thought it's red, now we have two answers, right? So it becomes a problem, right? So, and this comes again around the, if it's structured data, given past purchases, you want to predict future price. Yes, we can. Given weather, predict the shopping. Yes, we can. Given DNA, predict heart diseases. Maybe Probably some companies right now try to do that. And the last one is more interesting. Given history of a stock price, can you predict the price of the stock? No, we cannot. It doesn't matter how many times we try. It's like you cannot. The stock doesn't work, right? Again, you can predict maybe short period of time in front of you, but that's all. Now, the next thing that comes to you as part of a scoping is that when you build a project, or you work in a company, again, just assuming you work in a company or your own company. If it's your own company, you need to have a realistic expectations. The realistic expectation is that when you work in any company, when they want you to build something, they always say that we want 99% accuracy at least. It's like everyone wants a 99% accuracy. And you go, as your work is that you go, you do your due diligence and you do some basically the feasibility challenge, like a basically assessment, and you come back and say that, hey, the best human for this task can achieve this number. Okay, like, and that's not one human. So when we do human level performance, we actually do a pool across experts and you average the result. That's how we detect that. Okay, so when you say that human level, for example, has, I don't know, like a 3% error still. So we cannot, we might be able at some point reach to more than human, but we cannot just, right now just say that I want 99%. But the other thing is also is that you need to be realistic. I start to build working on this project. I cannot in the first run to give you the best model. Everything is iterative, right? So what you need to do as part of a scoping is being realistic and says that, hey, we have idea, this model, probably we have around 10% error. We are projecting over the time, Q1, Q2, Q3, we slowly reduce the error. And that's how basically companies basically work on, is like, you don't expect at first to have 99% accuracy. It doesn't happen. Sometimes you never actually get there. You get to maybe, like I personally, my boss will always like talk about, like we want 99% as a joke, but we reached to like, it started from 85%, gradually increased it to 96.7%, and it's kind of like a plateau. It doesn't go to whatever we want. And this is like 4 years later. Because realistically is that at the beginning, you don't have experience, you don't have data, it's like, it's not feasible. So for you also, you need to be sure that you put this as part of your scoping. Doesn't matter, here, wherever you work, don't give big promises. That's the message here. Just be realistic with yourself that, okay, there is a process here. I can't just, if you reach that first, 99%, perfect, right? But too good to be true also, that's a reality. Just keep that in mind. So the next thing is a diligence on the values. And this is also a really interesting thing. So it's like I will give these examples from the perspective of personal experiences. Whenever you're ML team, data science team, ML team, and you see things from the perspective of numbers. Your brain is just the way it is, that what's the metric that I'm going to reach? I want my threshold is, I want a model to reach this threshold, and then I'm good on train and test and things. Then the idea of the project comes from basically business metrics. So you have this product team, for example, and they have done some research and they came to a team and says, hey, we want to build this, for example, right? So from the product perspective, they have some business metrics, and business metrics could be, for example, we want to increase the revenue. We want the best model that can sell more, right? So they want to increase the revenue. The problem here is that you don't understand how I can increase the revenue. I don't know how the model that I make can, like, it's not an optimization metric for me to train a model to increase the revenue, right? So what does that mean? That means you're going to have this gap between what business wants from you and what you basically can train on. The idea here is that both teams, they need to learn to meet in between, right? So instead of basically try to be one end of the basically trajectory, just, hey, let's meet in between. So this example here is that, so you are doing this, I think it's like a search, it's like a search engine basically. And from ML perspective, the easiest metric for the search engine is that word level accuracy, right? So like how accurate is that, whatever the word level we're predicting, for example. The second level, you can go one level ahead of that. So it's that query level accuracy, right? Like how good are my queries on basically on average? Maybe you can go one level further than that. How accurate, how good is my search overall? Not just the query, the overall search, right? So there's different levels you can build toward that. In order to map what you train on this, but you map it, to get to this one. If my search result is good, that increases the user engagement because user is like, oh, this search engine is good, so I'm going to always ask questions from this search engine. If that happens, then my revenue goes up. So your idea here is that the reality is that you will be asked for this. You have this. You also need to meet with other team and try to understand this a way to basically map a proxy for mapping what you have to what maybe a product you want, right? So that becomes a reality. Just keep this in mind. It's sometimes this finding this product like a mapping is not that straightforward because again, what we develop on, we cannot develop a model on optimize on this and develop a model maybe optimize on the first 2, 3. Those are probably on the first one. Why? Because you want it to be more granular. So it's kind of like a more challenging. Now, the next thing here is that as part of your scoping is ethical consideration, right? Which is really important. There are two concepts we're going to talk about. Ethics and bias basically is really important, and you need to basically take that serious as an ML engineer that's going to be some professional in the market soon. So first thing is that is this project, it's adding something positive value to the market. Now, don't do something that you feel like, no, this is not a positive thing. So this is something wrong. Right? It doesn't matter if the company pays it, just don't do it. Is this project reasonably fair and free from bias? So think about this. Let's make one example. Let's say you have a classification model and you're all like, classification is like a 98% accurate on average, right? 2% we do misclassification. Oh, who cares? Right? That's a reality, right? It's like you probably say that who cares? It's like 2% is within the boundary. Now, ask the same question from yourself differently. What if you are the other end of the bargain? You're applying for university and you fall in that 2% that you get rejected as a false positive or false negative. What's impact that basically rejection could have on your life, right? If you think about it that way, you'll say that no, models should be fair. Models should be assessed for fairness and bias. Because might be one person is statistically, if you think about it, is nothing. But from a human perspective, that actually could have a really huge impact on someone's career, someone's life, right? So you need to be sure that the models, the data, the algorithms, the deployment, all of those, they're basically free of bias. There are so many, we will talk about bias a lot in this course as we go, but the basically truths, the truths that we don't want to hear is that most of the AI companies, they have biases, most of them. So it's like if you do a search online and it sees that the amount of bias that, how often companies pull out basically a model out of the market and they basically issue an apology. Like it happens actually a lot. Like over the last couple of years, how often basically, actually yesterday Apple did. Apple new Apple, what's it called? Apple Intelligence. What happens probably was that I think I saw the news on it. It's like the use the Intelligence to summarize news, right? And the news, this was on BBC. I read it today. The news, it summarized that that CEO shooter killed himself in prison because the app basically did a wrong job basically in summarizing the text, right? And they basically they took it down actually as of today because it's like so that's an example of like just something could happen and it could have a really bad impact, right? So you need to be sure that whatever you build, that it's not like that. Or bias also, it's not just that summarization. It could be all sort of like a negative amplifications or stereotyping that exist in the data. So we have most of the data, unfortunately, the data, the older data that we have, they haven't basically some sort of nature bias in this. Like, it's like a data has been collected with bias all these years, right? So like there's this there's so many banks that actually they always need to issue an apology. The most recent one was last year. That's actually it's like a Bank of Veteran Affairs, something like that, and this one also was on CNN. What happened was that they found out that they reject majority of, in compared to the basically white people versus black people get lots more rejection from the app, AI app that they have, and there's some bias basically in the rejection basically. So this type of thing exists. You want to be sure that when you build a model, you test for fairness and bias, not only in the data, in model, in algorithm that you choose, even the metric that you're choosing for evaluations. Those metrics, has basically bias in nature. Think about accuracy. By nature, it has bias in it. Because if you have imbalanced data, 99% of your data, if it's class 0, your model will say accuracy 99%, but you actually don't predict anything, right? So that's types of algorithm, types of evaluation metric, they could have induced bias by nature, so you need to be sure you keep this in mind. So the next thing comes around now, the milestone and resourcing. So as part of the milestone, basically, you come up first, you came up with some metrics, you say that, hey, these are the metrics, whatever I want to use in this project. This is how we're going to evaluate this project at the end. And you also come up with some software metrics. So you have an ML metrics, you have software metrics, like how good is this software overall, basically. And then you also have the business metrics that you want to be sure that you basically you can meet those also. Then you talk about what resources I need, what data, personnel, and stuff like that, basically. And you come up with a timeline, and then, again, we will talk again more of this, but normally as before POC, the code that you write doesn't need to be professional, like this doesn't need to be the cleanest. You just build it to be sure that I have something that can run. I test it as a POC. If it's a green light, then you spend the time on cleaning the code and be sure that it's like a well written and everything. So it doesn't need to be at first to like that. All right. So part of your almost every week we're going to see something like here. People plus AI guidebook. Okay. So we're going to have these small PDFs that they define give us some definitions, and then also these PDFs, they come with some worksheet. Okay, so every PDF comes with its own worksheet that you need to submit with your project. That means whatever you see in this PDF, you need to fill that worksheet with respect to your project and says that I answered this question. I have thought of these questions, basically. Okay, so this one starts with user need and defining what is a success. Okay, so the first thing, so small. Okay. The first thing we're going to talk about is that when you work with AI, there are a couple of questions that comes. That first is that what's the intersection of user needs and AI strengths? Like where AI basically adding values here, right? Assessing automation versus augmentation. You need to understand that should I basically augment, or should I build something as like a assessment, right? And then you have some design and like a reward function and evaluations. We briefly talked about those. But let's just start here. So let's say we have an image. So let's say you're building an app And this app is an app for running. So this is the example that being used in this PDF, series of PDFs. It's an example of you're building an app for running recommendation. So you're like a runner yourself and you're like, hey, I'm tired of the running paths that are always going. And you just get repetitive and I'm tired of running alone and stuff like that. So your goal is that I'm going to build an app that for runners in this with the same level, it basically recommends running path. Like, hey, run today, run this way because other people ran this way and they like it, similar to you. Or maybe it says that, hey, this group are going to run here. Maybe you want to go. It's like kind of like a finding a running mate, and maybe all other stuff, other recommendation that happen. So your goal is to build such an app, all right? So the first thing that as part of your not first thing, but like in your scoping, you have an idea. So in this class, you're building a product, right? So you have an idea. You're like with your team, and you see that you decide we want to build this. One of the first things earliest things that you need to do is to come up with what is the current state of this solution? If it's something that other people have done it, or it's something new that you're building it, right? If it's something that is out there, like other people they have done that, your question should be that what is the correct framework? So you basically create this map of existing workflow, and it's actually really good for you to do that because in a startup world, you either build something new or you pick something that someone else has done it and you do it better. That's the reality. So that's the idea of mapping existing workflows. So you create, like let's say, I know someone else has done it. So go with your friends on a whiteboard and write a workflow, draw the workflow of what do you think, how do you think currently this is being done? And then decide where do you think you can improve that workflow. That's a way for you to come up with an idea, right? If you can do it better and maybe better or cheaper, it's actually one of these two scenarios, then you can build your own company, But for your project, if it's something that is being done, create this workflow. This workflow should be part of your scoping, and then decide which part do you think you want to improve. It doesn't need to be all of it. You can just pick part. It's a product that you're building, right? But the goal here is for you to have this idea. I want to build this. I want to do this. Right? So have those definitions for yourself. So then you think about, hey, does AI add any values? Like, do I need to actually add a new ML model? Or no, I'm just optimizing the infrastructure around it. Maybe that's for your project. Maybe that's what you do. Maybe you don't need to build any ML model. You pick the existing ML model and you're just building everything around it better. That's a product because you're doing it better. You're doing it cheaper. You're doing it faster. So it's this example, for example, for this running, recommending different contents or prediction future events. Actually, this is not for the running. No. So it's just other examples. Natural language understanding, recognition of entire class of entities, detections. These are all good, could be scenarios that AI could do better, right? But when AI is not better, it could be scenarios like maintaining predictability, providing static or limited information. AI is not good in that. Minimizing costly errors. No, it's like if you want to minimize something that's costly error, you shouldn't use AI. You should give humans to do that task, right? Because it's costly error. Complete transparency. Most of the AI these days did not. Hopefully we're going toward that. It's like interpretable or transparent, basically AI. Optimizing for high speed and low cost. We know it's opposite for AI. So you cannot basically do something like that. Automating a high value task, probably you should ask humans also to do that. So these are type of question that you need to ask. Should I use AI or should I use human for this? Now, assessing automation versus augmentation. So this is really important, especially for all of you that you're going to build AI product, as you go through for the next 40, 50 years, probably in your life, you're going to build AI products, right? So maybe you always need to have this mentality, ask this question that when I build something as an AI, when I build an AI product, is that AI product going to add values to someone's life? So what does that mean? So let's say, and this comes around the augmentation versus automation. automation, basically we say that automate and task with AI, if that task is brutal, if that task is tiresome, it's like something not fun. Someone in a factory, they need to do lots of work and you can replace that with humans, with robots, right? So that's where you can do basically use AI. That's a good thing, right? But when it comes around augmentation, basically the idea here is that don't try to take a job from people if they're having fun with it. If people enjoying someone, it's like a basically, it's like there has been this movement around, you should not use basically AI to build and sell books or build and sell images, stuff like that, because that's someone's job that they're actually having fun, art, So I don't know if you know that on Amazon, they were selling lots of books that written by GPTs. Okay, and they keep trying to remove the Amazon, is putting ban on those, remove those, So that's it should be. But someone just using a model and just building something random, some fictional that someone else spends lots of time and joy, and they're enjoying it, right? So you should not basically do that. So you need to always remember when to automate. If it's tasks that it's not fun and it can increase efficiency, improve human safety, reduction of tedious tasks, enabling new experience that they weren't possible, like that's something that you basically can do automate. But or like people lack the knowledge or ability to do the task. But when to augment, augment means that help humans with that. Like for example, think about like what's called the Photoshops and stuff like that. That lots of basically artists they use Photoshops. So Photoshop, what they did, they basically add some sort of like a generative AI as an augmentation that now helps the basically artists to build better arts. Instead of just saying that, okay, you don't need to do that. Click on this and build the art for you. But that becomes the augmentation concept, right? So increase the user enjoyment of that, higher level of user control versus over the automation, greater user responsibility and fulfillment, increase ability to scale basically, and increase the creativity. So you need to keep those in mind when you want, anytime in your future, you want to build an AI, just ask yourself this question. Like, should I augment? Should I basically automate? If it's basically one of these two scenarios comes out. Now, and again, this part, it comes, we're not going to go over this a lot, but like a reward function or like evaluation metrics. It's important for you to understand that the importance of the metrics that you are selecting, what are the, you have false positive, false negative, right? What's the importance of each versus the other one, right? Which one is more important? Think about, again, think about the concept of what I said, admission to university, right? Maybe if a university using an AI to accept or reject, maybe they should have a model that has more false positive, and more acceptance versus more false negative, right? Well, how? So you accept more without telling to the user maybe, and maybe the portion that you accepted and you were not sure, because it's a threshold again, right? That confidence, you're just sending it to some humans to evaluate the result again. That's something that happens in healthcare if you think about it. So in healthcare, if you go to, it's really hard to use AI in healthcare because the adaptation is not that easy, right? Why? Because you can't expect AI to not make a mistake, and it's humans' life at stake, so it's going to be harder, right? So think about this: you go to someone goes to a doctor and they have some certain disease, and you want to know if you have the disease because you want to quickly to find a cure for it. Now, if you go to an AI, if you're using an AI, they normally have higher false positive in healthcare than false negative. They rather to tell you have disease even if you don't have. So you come back for a second test and then you say you don't have it, voila, everyone is happy. Whereas if I tell you don't have, maybe you never come back for a second test until something goes wrong. So you see there is a weighing over there, like which one you care more about versus which one you care less, right? But also it's important to remember there are certain tasks that, like not, for example, healthcare, but like in concept of cybersecurity that I work is that if we have, like, you really care to not miss something, like something that dangerous, right? So you want to be sure that you, for example, you stop something. Like if there's an attack or something, you want to stop it. But so maybe you increase your false positive, decrease your false negative, right? But then if you increase your false positive too much, you know the story of the boy who cried wolf? You keep shouting that attack, 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 and then just at some point, the concept is called user fatigue. User is like, I'm going to mute the basically notification from this app, and then they don't trust your app anymore. All right. So you need to have this idea in your mind that like what is more important versus the other one, but also be sure that you don't fall from the other end. Like you don't basically give too much attention to one, ignore the other one, and then the other one has finally its its own basically downsides. So then come up with those metrics for your project, what you care about more. And then think about precision, recalls, trades off of these ones, basically what you want to use. I'm not going to talk about, so I expect you to know those. Then the other thing is that here. So assess inclusivity. So this is really important. So inclusivity is kind of also basically work with the bias concept here or model resolve. So think about this. So you have certain basically you have certain application. Let's say you have an app that basically make a recommendation system. So recommendation system as of I am a vendor. I basically go on Amazon, for example, or Google, and I put an ad for what I'm trying to sell. Okay. And customer comes and basically they do search for that vending, basically whatever product is that, and you expect your product to show in the search result, right? Now, you look at the average, basically average error, average F1 score, average AUC curve or something like that, and you see like, oh, we have like a 98% basically AUC, perfect, like. The problem with something like this is that it doesn't guarantee inclusivity. What inclusivity means? That 2% that you are missing, that let's say this is 2%. Maybe this 98% comes from top large basically vendors because they dominate the market, they have lots of data, and this 2% comes from all small vendors that every time they try to basically sell something, right? So you never recommend their product, you always recommend the large company. 2 years ago, I think Google lost another lawsuit in Europe. I think the idea was that the Google promoting system, the ads, was always like a promoting larger American or corporations instead of small European, basically, and they lost another lawsuit over that. The AI model was biased basically toward that, right? So that's the idea of inclusivity. So again, average result doesn't mean good. You need to look at individual level results. And that we're going to talk about this concept called data slicing. You slice your data in demographic regions, I don't know, like gender or even sometimes individual. And you want to be sure that you have the same level of performance for everybody, not just for a large group because they had more data in compared to small groups. So, assess inclusivity, be sure that you monitor basically over time and imagine potential pitfall. And this is what I talked about, that you need to think ahead of time. What could go wrong? When you build it, as you build it, think. Be honest with yourself. What could go wrong? I know, because when we build something, we're like always like, nothing could go wrong because I'm building it the best. But be honest with yourself. Like, what could go wrong? You know by default which part potentially has some flaws in it. Just be sure to monitor for it. That way you detect it ahead of time rather than wait for it to break and then, just spend the time to fix it. So remember to account for negative impact. And as I talked about it, that admission to university, that has the negative impact. Just remember for those ones. Okay. So that's the overall of this document. This document again comes with this worksheet. It's already uploaded. So for your project, basically, you need to fill this. You need to answer these questions. That means you have thought about these questions, you know, you have some ideas what you want to do. So every week when you get this types of document, basically, not that you need to submit it next week. You need to have it part of whenever is the submission for your project. Okay. All right, so I'm gonna stop here and I'm going to talk about quickly about your